Hello, my name is John Wilke, and this is my senior project proposal entitled Engineering the Perfect Beer. In this presentation, I will be discussing the objectives, methods, time frame, cost, and deliverables associated with this project. There are multiple objectives associated with this project. The first objective will be to design a microbrewery using concepts previously learned in chemical engineering classes. These concepts will focus on thermodynamics, fluid mechanics, heat transfer, reactor design, process simulation, and energy balances. The next objective will involve physically brewing small and medium scale batches. These batch sizes will consist of 1 and 5 gallons. Once these batches have been completed, they will be scaled up into an industrial sized quantity and then be used in the microbrewery design report. When designing the facility, equipment will need to be selected based on its use in the chemical process. Tanks, reactors, piping, and pumps will be required in order to transform raw materials into finished beer. Engineering calculations will be performed in order to make sure the brewery can operate safely and efficiently. The chemistry of each beer to be produced in the facility will be analyzed and included in the report. Production will be estimated based on the size of the facility and the production rates of the equipment. These will be useful tools to calculate the profit of the facility. A return on investment calculation will be made in order to prove that the microbrewery design would be a worthwhile project to pursue. The physical brewing will start with 1-gallon batches and focus on the ratios of raw ingredients and the chemical process. Next, 5-gallon batches will be created using scaling up factors and more engineering calculations. The purpose of 5-gallon batches is to provide a stepping stone between small scale and industrial scale. Using the batch scaling from 1 gallon to 5 gallon, it is possible to predict accurately the scaling factors from 5 gallon to industrial size. Although a industrial scale size will not be physically produced, a recipe will be produced and inserted into the basis of design report for the microbrewery. When looking at the time frame of the project, it becomes obvious that physical brewing will happen at the same time as the design of the facility. These activities can be run in parallel because they do not interfere with each other. The majority of the brewing process involves waiting around for the fermentation reaction to occur. During this time, the majority of the focus can be spent on the designing of the microbrewery. 1-gallon batches will be produced from October of 2016 to February of 2017. During the start of February 2017, the first 5-gallon batch will be brewed in parallel with the last 1-gallon batch. Batch scaling from the 1 gallon to 5 gallon will occur during January of 2017. The final industrial scale-up calculations will be completed during April of 2017. The month of May 2017 will be reserved for the finishing compilation of the conclusion of the physical brewing and the design of the facility. The microbrewery design is broken into 3 sections: background design research, basics of facility design, and engineering calculations. All of these sections are allotted significant time portions in order to complete. The entire cost of this project lies in the physical brewing stages. It is separated into the cost of the brewing equipment and the ingredients required for each batch. The most significant individual cost is the price of the 5-gallon brewing equipment. The total cost sums to $325, but is to be split between all team members. These pricing estimates are fairly generous, so the total project may very well end up costing less than the projected scope. Several rewarding deliverables will be produced from this project. Although the microbrewery will not actually be constructed, the design report will serve as a great starting point if someone were to actually construct the facility. Successful and finished batch recipes can be used for further homebrewing endeavors. Lastly, 15 gallons of homebrewed beer will serve as a consumable and rewarding product of hard work. This concludes my presentation on engineering the perfect beer. If you have any questions, please feel free to leave them in the comment section below. Thank you.